Hi, and welcome to today's Engaging for Missouri webinar. I'm Alice Roach from the Division of Applied Social Sciences at the University of Missouri, and I'll be your host today. With each of these 30-minute webinars, we intend to share research-based insights that leaders like you can apply in your own work to benefit and strengthen the state's agriculture and food system, hospitality sector, and communities. For today's presentation, we had a last-minute change in speaker. We're happy to have David Van Ripper here to share about data quality under differential privacy. Before I invite David to begin, I want to share a few housekeeping notes. First, we'll close today's webinar with a question and answer session. Those of you who connected to today's webinar via your computer can submit your questions in the chat screen. So to open that chat screen, just click the chat button that you see at the bottom of your Zoom window. If you joined today by phone, then you may email me your questions at roacham@missouri.edu. Second, all attendees are muted and may not start their video. Third, if you encounter any technical problems during the webinar today, then you can let me know by either submitting a comment in the chat screen, or you can also send me an email at roacham@missouri.edu, and I'll do my best to help you troubleshoot. Fourth, we will make a recording of today's presentation available to you. You can look for an email sometime tomorrow that shares more about where you can access that recording. Additionally, you can find an archive of all of our previous Engaging for Missouri webinars on our division's YouTube channel. So now we'll transition to the topic of today's webinar, which is titled Data Quality Under Differential Privacy, Missouri's Counties, County Subdivisions, and Census Tracts. Presenting is David Van Ripper, who is the Director of Spatial Analysis at IPUMS and a co-principal investigator for the National Historical Geographic Information System. So thank you, David, for presenting today. If you could please unmute your microphone and start your video, then we can begin today's presentation.
Great. Thank you, Alice, for that introduction. Thanks for having me, everybody. I'm excited to talk to you today about some changes that are happening with census data and how it may impact the work that you're doing in the state of Missouri. Protecting the privacy of census respondents while publishing quality data are dual mandates for the U.S. Census Bureau. In August of 2018, the Bureau announced a major change in their approach to privacy protection. According to the Bureau, increases in computing power and access to large individual-level databases mean that their traditional disclosure avoidance techniques, which is mainly swapping, no longer provide strong enough protection. In response, the Bureau is adapting a framework based on differential privacy for its 2020 disclosure avoidance system. Differential privacy entails injecting random noise into nearly all published data in order to guarantee a minimal risk of privacy loss. But that privacy protection comes at a cost. Published data will be less accurate. So today I'm going to go through two aspects of this new system for you. One, I'm going to provide a really quick overview on how differential privacy is implemented using a toy example. And then I'm going to look at some sample data that the Census Bureau has recently released and compare that with 2010 summary file 1 data to show you the types of impacts that you may see in Missouri. So we start with how is differential privacy implemented. So here we're going to use a toy example to explain the basic implementation of differential privacy. One thing that I need you to know at the outset is that differential privacy is a mathematical definition for guaranteeing privacy. It is not an algorithm that's applied to the data. Computer scientists have designed many algorithms that implement differential privacy. And the one I'm going to present in just a second is probably the most naive possible algorithm you can have that implements differential privacy. So we start with a microdata set that contains two variables, the sex of the respondent and a school attendance variable. Sex can take on 2 values, male or female, and the school attendance variable can take on 3 values, never attended, currently attending, or attended in the past. We take the microdata results and we create a cross tabulation from that true data. So here we have a 3x2 cross tabulation. You can see that we have 3 males who've never attended school, 12 males who are currently attending, and the overall population in this survey is 100 people. In order to make this data set differentially private, we construct a Laplace or a double geometric distribution, and we draw one point at random from that particular distribution, and we then inject that random value as noise into the cell counts. And the spread of the Laplace distribution is determined by this value epsilon, which you can see along the bottom here. And epsilon is specified by the analyst or the data producer and is independent of the values in the cross tabulation. And the way to interpret epsilon is it's a relative measure of privacy. The smaller the value of epsilon, that means that you're going to have more privacy afforded to respondents. And the smaller the value of epsilon means we're going to inject more noise. The noise values are going to be larger that we inject into the counts. As epsilon grows, there's less privacy afforded to respondents. That just means we're injecting smaller noise values into the counts. The magnitude of the noise is independent of the measured count. So you could theoretically draw a very large value from a noise distribution, add that to the cross-tabulated count, and get a very large value or a value that could be, for example, below 0. So here in this example, I've drawn noise distributions from the Laplace, and here I'm adding it to each cell in the crosstab. And now you can see that we've decreased the count for males never attending from 3 down to 2. Male attending stayed the same. We drew a random value of 0, so it stayed at 12. But you can see for the females who never attended school, we've tripled the count from 4 to 12. So we've really increased the error in that particular count. Now we've protected their privacy, but that's not going to tell us much if we're trying to plan for the number of people who are maybe starting school in a couple of years. You can also see that the overall count in the particular survey is now 108. So you can no longer make a one-to-one relationship between the original microdata and the differentially private counts. The key thing to know about this particular mechanism is that there's a lot of policy decisions that go into the construction of these differentially private algorithms. And the key takeaway for you all today is that these policy decisions are really, really important. And there's a group of people at the Census Bureau called the Data Stewardship Executive Policy Committee. They are going to be making a number of policy decisions related to the differential privacy algorithm. And those policy decisions have a pretty substantial impact on the quality of the output data, which you'll see in a second. So there's 3 main policy decisions that have to be made. 1, how much overall noise should be injected into the data? 2, how do we allocate that noise among geographic levels? In other words, which geographic levels do we want to make more accurate or less accurate? Do we want to focus on states or counties? Do we want to focus on census tracts or places? That's a fundamental policy decision that impacts the accuracy of counts for those particular geographic entities. And finally, how do we allocate the noise among queries? For example, do we privilege the total population count to the detriment of the accuracy for age or sex or race or Hispanic counts? And so these are all policy decisions, and these are going to be made by a group of people who probably have competing priorities. And the decisions are going to have an impact on the quality and utility of the data, as I'm going to show you in a second. And so if you all are interested in this, it's fundamentally important for you all to think about how you would use these data and think about which statistics, which geographic entities are you most, do you use the most, and that you'd want to use in the future, and to provide feedback to the Census Bureau about use cases where you'll use decennial census data. So now let's look at a few different examples of data to show you what this looks like. So I'm going to compare 2 versions of differentially private data that have been published by the Census Bureau with 2010 summary file 1 data. The V1 dataset was published in October of 2019, and the red boxes on the box plots in the future slides will represent this version. The V2 dataset was published in June of 2020, and the blue boxes on the box plots represent this version. V1 and V2 were generated by different algorithms and used different sets of parameters. And what I've done is I've taken counts from V1 or V2, and I've subtracted the equivalent count that was in summary file 1. So what we're going to be looking at here are differences between the differentially private versions and summary file 1. So to start, this box plot compares the differences between V1 in red and V2 in blue with 2010 summary file 1. And here we're looking at just total population counts for Missouri's counties. I divided the counties into quintiles by the 2010 summary file 1 total population. Quintile 1 contains the smallest counties by population, and quintile 5 contains the largest counties by population. If we examine the results from V1, we see a positive upward bias for small counties. In other words, the differentially private count was higher for those counties than it was in summary file 1, and a negative downward bias for large counties. In these cases, the differentially private counts are smaller than the 2010 summary file 1. And you can see that as you move from quintile to quintile, that bias goes from a positive bias to a negative bias. If we look at the blue bars from V2, that bias is not apparent in V2. And if we look at the differences between V2 and summary file 1 are substantially smaller than the differences that we see between version 1 and summary file 1. Examining the differences for the Black alone population for counties, we don't really see bias in V1 or in V2, and V1 and V2 are relatively similar by quintile. Maybe V2 for quintiles 2 and 3 have a little tighter interquartile range, but for quintile 5, the IQR in V2 is a little bit higher, and we see a few more outliers in V2. Here, we're examining differences for the population age 65 plus. And as we all know, in the world of COVID, this is a particularly important age group to study, given the risk that they're at for developing COVID. Here we can see that the interquartile ranges for version 1 in red are consistently smaller than they are in V2. And we have 3 fairly substantial outliers in quintile 5, where the differences at the county level are between 1,000 and 2,000 in the differentially private data when compared to summary file 1. Here we examine the differences for county subdivisions in Missouri. So county subdivisions subdivide all counties, and these would be townships or villages, those types of entities. I'm not as familiar with the Missouri administrative geographies as I am for Minnesota, but I wanted to show what these results look like. We observe smaller IQRs for version 2, but if we look at the median errors, they're fairly consistent between the 2 versions. Compared to the county total population differences, the magnitude of errors are larger for the county subdivisions. So we're seeing, errors on the range of 200 to negative 200 for most of the quintiles. We get a little bit bigger ranges for quintile 5. This plot shows the difference in the Black alone population for county subdivisions. Like counties, V1 and V2 are fairly similar by quintile. In all likelihood, there's probably a lot of county subdivisions in Missouri that have fairly low Black alone populations. If we look out though at quintiles 4 and 5, we see maybe a few more outliers in V2, particularly in quintile 5. Finally, looking at the age 65 plus population, the IQRs are very similar for the 2 versions, but again, in quintile 5, we're seeing some fairly large outliers, up to, again, 1,000 to a negative 1,000. Finally, we consider the differences for census tracts. As with counties, we observe a bias by population quintile. This is the difference for total population. We observe that bias by population quintile. The median error for quintile 1 is positive, and that slowly decreases until the quintile 5, when the median error is negative. That bias is gone in V2, and the error range is much tighter around 0. Looking at age 65, again, we observe smaller IQRs for V1 compared to V2, and more outliers in V2. Another key aspect to pay attention to, though, here is the overall differences, magnitude of the differences. So the mean number of persons age 65 plus in quintile 1 is 301 people in summary file 1. So if 301 people is the mean, you're going to be getting potentially outliers that are the mean plus or minus over 200 people. We're not going to necessarily know very much about the actual counts of people age 65 plus in census tracts throughout the state of Missouri. In quintile 5, the mean number of people is 914. So we're looking at 914 plus or minus up to 500. Targeting services to census tracts based on these differentially private counts for those age 65 plus is going to be much more difficult under differential privacy. So I've talked a lot here about the differences between V1 and V2 and why one is different from the other. And as you can see, we do get different results, right? Especially for total population, the error ranges, the differences are much narrower in V2 compared to V1. For age 65 plus, we see that V1 has narrower error bounds than we do for V2. So what's happening? Why is that the case? So how do V1 and V2 differ with regard to those policy decisions? For V1, voting age by race, by Hispanic ethnicity was privileged in the policy decisions. Those counts were made more accurate at the expense of things like total population. In V1 in particular, persons aged 65 and over were privileged. They received a direct allocation of the epsilon. And so that's why we're seeing narrower error bands in V1 for the age 65 plus population compared to V2. Counties and tracts were privileged over county subdivisions. So counties and tracts received a direct allocation, county subdivisions did not. And the algorithm that was used to produce the data created that population bias that we saw when we looked at the total population difference. For the second version that was released, total population was privileged. So total population received a plurality of the allocation of that epsilon value at the expense of race or age counts. Again, counties and tracts were privileged in this case, and the algorithm was tweaked to try to fix that bias that was being introduced. And if I had an hour, I would go through all the details about how that happened, but in 15 minutes, I can't go into all those details, but this is an ongoing research that the Bureau is doing, and they are working very hard to try to make better versions of the data. But the user community thus far has been very disappointed in the overall quality and utility of the data. And if you look at some of those error metrics, you can see that trying to use these decennial data, particularly thinking about rural areas or areas with small populations, could really inhibit research and service provision in those areas. So before I leave, I want to point you to a couple of sets of resources. We at NHGIS provide access to these tabulations from the demonstration data. We've actually linked it up with summary file 1 counts in the same CSV, so you can look at differences between the two products and do your own analysis. And then in December, there was a large workshop put on by the National Academy of Sciences where you can see a lot of users from Alaska and Minnesota. I was there, Colorado, talk about different use cases and talk about what they found when they analyzed the V1 data. So that's it. Hopefully we got some good questions, and I'm happy to answer them. And if you have further follow-up questions, go ahead and send me an email. It'll be on the slides.
Excellent, Dave. Thank you. If you do have a question, please go ahead and submit that in the chat screen, or you can also send it to me in an email. You can direct that email to roacham@missouri.edu. Dave, our first question here is from an attendee, and he writes, what is the purpose of this privacy concern on descriptive statistics on such large response numbers? So privacy would make sense if a researcher were accessing individual records, but does it make sense for the descriptive statistics?
So in the early 2000s, a couple of computer scientists at Georgetown, Nissim and Denur, published a paper where they were able to take the descriptive counts for geographic areas and essentially construct microdata, individual level records out of those descriptive statistics. And then they've been able, once they can reconstruct the underlying population, they can link that up with individual level data, say purchased from a credit bureau or other entity, and try to infer variables such as race or ethnicity that might not be recorded on those credit bureau statistics, and they can infer someone's self-reported race from that. The Bureau is particularly concerned about things like household structure. So let's say you're a same-sex couple that is not publicly identifying as that, but if you identify that way in the census, maybe you could get reconstructed and you could be identified. And the growth of individual level data from Facebook or other social media networks has made the Bureau very worried about this particular it's called a reconstruction and re-identification attack. And so they're very concerned about publishing all of these statistics even for geographic areas. You can do that reconstruction.
Okay. So because of the change in how the Census Bureau is working to maintain privacy, what are practices that data users can use to make fair comparisons between the 2020 data and the data that were captured earlier so we can see trends and so forth?
So one thing that has to happen, and we have to push the Bureau for this, is that if they're going to be injecting noise into these data, they have to provide us with some kind of error metric, right? So if you use the American Community Survey, they publish a margin of error for every statistic in that survey. We need something like that so that we can know whether how accurate or how much uncertainty is on that statistic. Now, in the decennial census, that measure of uncertainty has not been something we as researchers have had to deal with. As of today, though, the Bureau has not yet said whether they're going to put out those measures of uncertainty, and we as the research community must push them to do so, because otherwise we are going to be kind of shooting in the dark about what types of trends and changes are we observing actual trends or changes, or are we observing trends or changes that are artifacts of the noise injection process? And we're going to have to just learn more about differential privacy and how to analyze the data. It's a new method. It's about 14 years old. It hasn't been broadly used. The census release will be the largest publicly available data set that's ever been produced using differential privacy. So they're experimenting on a bedrock of our democracy with a method that is pretty well known in computer science, but social science don't know much about it yet.
Sure. This attendee has two questions. First, will the epsilon numbers be released for the data? And then also, as a follow-up, has there been consensus regarding the optimal trade-off between privacy and the utility in defining epsilon?
So the epsilon will be published. So the one good thing about differential privacy is all the parameters can be published. So they can publish the global privacy loss budget, the global epsilon, and they can publish the allocations that were used to particular geographic levels of queries. So that we can do. But in terms of the trade-off of utility versus privacy, that's an ongoing question that people at the Census Bureau are struggling with, and there's lots of competing priorities, right? So if you're a rural sociologist, you really need to get accurate data for rural areas. But if you're a privacy person, those areas have small counts. And so you want to try to protect their privacy. And so that's kind of what that trade-off looks like. And it's really a sociological question. It's not you can't just plug these numbers into an algorithm and it spits out the optimal value of epsilon. It really has to be argued over and discussed by people. And I think that we are starting to have that conversation now, but it also feels quite late in the game to have that conversation, given that the data need to come out less than a year from now. And so I think the conversations are happening, but we're all just kind of getting up to speed on how to even have those conversations.
Great, thanks for that. Another attendee question here. It seems like accurate vital statistics like mortality rate by age, race, sex, by county will not be possible with differential privacy. And are the folks at the National Center for Health Statistics looking into this? So
yes, as far as I know, people at the Centers for Disease Control and CHS are aware of this. I think they were also somewhat caught unaware that this change was happening, and so they like all researchers have been trying to get up to speed on what this means. I think, but you're absolutely right. These data are used as denominators for a lot of values, and remember that the decennial is used as the base for the POP estimates program, which are often used to generate these denominators. And so, what is the differentially private noise injection? What are the downstream effects are? And so we need to be talking to all the people that are involved in this and letting them know that this is going to be happening.
Sure. We have another question here that's getting at sort of the implications of what this differential privacy means. Will this privacy policy be used when the census is used for allocating U.S. representatives, or will the actual data be used for that single purpose?
That's a great question. So the apportionment counts are based on non-noise injected data. So they are based on the counts at the state level that are not noise injected. Those are what are called invariants in the differential privacy literature, and the Bureau has stated that the state level pop counts for apportionment will have no noise injected into them.
Okay. Will the Census Bureau apply this differential privacy approach to other census data that it captures? For instance, there's an economic census. Will those data be subject to differential privacy too?
So I would expect over time that other products produced by the census will, if they're adopting it for decennial, I assume they will be adopting it for other products. The Bureau has come out and said that the American Community Survey will transition to using differential privacy, but not before 2025. So they need more time to do the research. I would expect other data products to that they will work on that. I think though it's up in the air about when that will happen. They have not said anything publicly about products besides decennial and besides ACS.
Okay. So many of our viewers will be familiar with farms completing the Census of Agriculture every 5 years. So will other government agencies like USDA consider differential privacy to protect the privacy of respondents?
I would expect that other agencies will definitely be looking into differential privacy as a possible way to protect privacy. I think that a lot of agencies follow what the Census Bureau does. I think the Census Bureau tends to be the leading agency, and other groups follow. I think, but we don't know yet. I think the ag census has definitely got a lot of. They tend to use more suppression, I think, and more cell count suppression. And so I think they have other mechanisms for doing privacy, but I would not be surprised if differential privacy comes on the radar screen of other data providers.
Okay, great, thanks for that. Will applying differential privacy practices to the 2020 census data add time to that window that's typical between when we close the census data collection and when we actually see the published results?
So no, a run of differential privacy takes about 2 to 3 weeks on their cloud system, which is about what it would take to do their traditional disclosure avoidance technique. So it's not going to add any more time. I think the delays in census counting is going to have a way bigger impact than the differential privacy implementation.
Okay, so when should we expect for the 2020 census data to be released then? Did you say sometime next year?
So yeah, so the PL 94-171, which is the redistricting data set, that's the first release. That is currently targeted for release beginning in the end of February or early March 2021. And that comes out on a state-by-state basis over like a 3 or 4 month time period. New Jersey and Virginia get their data first because they have to redistrict before elections in 2021. And then other states will get their data after that.
Great, thanks. Do researchers and communities and other stakeholders still have an opportunity to share input into how differential privacy is implemented? And if so, how do you recommend that they share that input?
Yes. So if you go to one of the 2 websites that I linked to before on NHGIS, we have the email addresses for the Census Bureau's team that's taking input from users. And so the email addresses are there. I would recommend identifying specific use cases where you've used decennial census data and comparing, how, say, funding allocations might be different under differential privacy versus not, and trying to come up with ways or heuristics or measures of saying, we need accuracy of some level in order to use the data for this particular purpose. Statutory use cases are very powerful when it comes to the Bureau because if there's laws that require particular funding allocations, that can kind of build into their decision-making process about what to privilege over what not to privilege.
Great. Well, thank you so much, David, for sharing today's presentation, and thank you to our audience too. When you exit Zoom, a post-webinar survey will load in your browser. Please consider responding, as we'll use the results to improve the webinar experience and also brainstorm future webinar topics. Again, you should receive a recorded copy of today's presentation via your email sometime tomorrow. Join us for our next Engaging for Missouri webinar on Wednesday, September 2nd. Dr. Scott Brown, who is an Associate Agricultural and Applied Economics Extension Professor, and he's also CAFNR's Director of Strategic Partnerships. He will share a presentation titled A Possible Path Forward for the Show Me State Food, Beverage, and Forest Products Manufacturing Initiative in a COVID-19 World. So thanks again for joining us and enjoy your Wednesday. Thanks, Dave.
Thank you. Bye.
Bye.